FizzBuzz is a common coding challenge normally used in job interviews. The rules are simple. Print out the numbers from 1 to 100. If the number is a multiple of 3, print out the word fizz. If the number is a multiple of 5, print out the word buzz. And if it's a multiple of 3 and 5, then print out FizzBuzz. And then for any other numbers, just print out the number itself. So to start out, let's define our API for this problem. We'll start by making an interface. We'll call it FizzBuzz. So let's create a function called FizzBuzz, and it takes an integer as a parameter and has a return type of string. And let's add a Java comment explaining what this function should do. And we'll add the criteria mentioned earlier. And now let's add some constants. These can denote what we expect the function to return. So there's our FizzBuzz interface finished. One advantage of programming to an interface is that we can separate the what from the how. In this interface, we simply say what we want to happen. We don't care how it's done at this point. So now I'm going to create the implementation of our class. So we'll create a new class and we'll implement the FizzBuzz interface. And we can use Ctrl-I to quickly implement those methods. Now we can make use of the Java comment on the interface to see what our class needs to do. And because we made use of the Kotlin references, we can click the links to see more information about certain items. So before pressing on, let's quickly set up JUnit. So let's mouse over our FizzBuzz function and press Ctrl-Shift-T. This will automatically create a test for us. So now let's think back to the first criterion. If I is divisible by 3, return fizz. So let's name our first test. We can split our test name into 3 parts: the function we're testing, the input, and the expected output. So let's create our first test. Let's create an instance of FizzBuzz. We'll set actual to the output of the function. We'll set expected to what we expect the function to return, and we'll give the test a run. And as you can see, the test fails. We've not yet implemented. So let's talk about test-driven development. Test-driven development was created by Kent Beck in the late 1990s. It was originally used as part of extreme programming. TDD has been adopted by many companies, and it looks great on your CV. Test-driven development breaks up the coding cycle into 3 separate stages. In the red stage, we create or modify tests for a new piece of functionality. It's called the red stage because the test should fail at this point. Next is the green stage. In this stage, we modify our code to make the test pass. And finally is the refactor stage, where we clean up our code. So now that our test has failed, let's modify our production code so that it passes. And let's run that. And we're green. Now you may have noticed this is not the full implementation. This is just the smallest step possible to get the test to pass. This is essential for TDD, as it allows us to prove that the test works alongside the code. And considering we've not really written much code, there's no need to refactor it. So now it's back to the red stage. Let's implement a new test, this time for buzz. And just as a reminder, this test is testing that if we pass in a number that's a multiple of 5, then we expect that the function should return buzz. So now let's rerun those tests and see what we get. As you can see, the new test we've written has failed because it expects buzz, but it got fizz. So now let's get back into the green. So we'll modify the existing implementation to use an if statement. We'll make use of the module operator to make sure that the number is divisible by 3. If it's not, we'll check if it's divisible by 5. And then for the final else block, we'll just put a to do. The reason this works is because to do has a return type of nothing. That means that this function will never return anything, which essentially means if you call this function, it's going to throw an exception. So now let's rerun those tests. And we're in the green. Great. So now let's do a refactor. Instead of saying I mod 3 equals 0, what if instead we used the main language? The Java doc for the FizzBuzz function says if I is divisible by 3. So why don't we use that same language here? An infix function is a function that exists on a member and can be called without parentheses. Let's implement it. So let's replace those existing moduluses with our new infix function. Just to be sure we haven't broken anything, let's rerun the tests. Okay, so let's head back into the red stage and let's write a test for FizzBuzz. And let's give these tests a run again. And as expected, we're back into the red. The tests are failing because expected FizzBuzz, but we got fizz. So let's go ahead and implement that for 3 and 5. We can optimize 3 and 5 to 15 because 3 and 5 are prime factors of 15. So let's give these tests another run. So for our refactor this time, we may notice that all of these functions are doing the same thing, just with different parameters. So let's parameterize them. So I start by adding the JUnit parameterized test dependency to my Gradle. Then I create a parameterized test that replicates the test above. And then finally, I add a companion object that provides the parameters for this test. So to explain what I've just written quickly, the parameterized test annotation marks a test as parameterized. A parameterized test takes its inputs via function arguments, in this case input and expected. Next, you declare a static function that provides the test data. Finally, you can associate the two using the method source annotation. If no parameter is passed to the annotation, then it looks for a function with the same name. This is known as data-driven development, and it is very powerful. So to finish cleaning up, we can remove the old tests as they're no longer needed. Now looking back at the criteria for the function, we've got one case left, and that's to return I if none of the above criteria apply. And all we need to do now is add another argument, and we can run the test again. And the tests fail, with an operation not implemented. And that's because of the to-do function. So let's replace it with i.toString. Now when we get to the else block, we'll return the number that got passed in as a string. Now we can run the test one final time, and they all pass. So we're very nearly finished. Let's add some more arguments. And if these pass, we know we're finished. So let's give those a run. And there we go, we're in the green. And now we're confident our tests run correctly, we can maybe do a bit of a bigger refactor on this by replacing it to a when clause. If statements are normally used for binary choices. In the case of having 3 or more, you should probably use a when statement instead. And that looks miles better. And now let's run our tests one final time. And there we have it, test-driven development. Thank you very much for watching. As always, if you enjoyed the video, please leave a like and subscribe, and I'll see you in the next one.